Dear students, today we are going to talk about the first experiment of this class, that is which is used to measure the unknown resistance by using a device which is known as meter bridge. Here you see in the meter bridge we will talk about the different aspects of this device. You know, it is based on the principle of Wheatstone bridge. Here you can see in the Wheatstone bridge what we have. We were having 4 arms having different resistances, and so is the case here also. A galvanometer is connected across and some cell is applied in this way to the bridge. See, we must recall we have kept this value as P, this as Q, this one as R, and this one as S. And in the balance state, when a galvanometer is showing no deflection, means no current is flowing through the galvanometer, then in that case we have proved that P by Q is equal to R by S. So P by Q for the balance state is R by S. Now here if you compare, you see here you see we have a metal strip having the knobs to connect the wires. Here we have one resistance P, and here we have another resistance Q, and they are connected through the metal. So it is just like that. If you compare this point, you can call it as A, and you can call this middle point as B, and this point as C. This is C, and lastly this is point D. So, and here you see we have a long wire, 1 meter long wire, and the jockey is connected to galvanometer, and this jockey is shifted over the wire, so that we shift it on the left, on our right, so that the galvanometer finally comes in a position showing no deflection in it, means no current is now flowing through the galvanometer, and for that state we call it a balance bridge. And once it is done, we can write the relation P by Q. We can use the relation P by Q is equal to R by S. So if the resistance of this arm length L1 of the wire is R, and if the resistance of the remaining part of the wire length L2 is S, then we can write P by Q is equal to R by S. So here we have written P by Q is equal to R by S. This R value is what? R we know is relation is R is equal to rho L by A. So resistance of the length L1 of this wire, that is length of wire AD, will be given by rho L1 by A, and similarly for the remaining part of the wire we will be given by rho L2 by A. Since resistivity, same wire is ADC is having the same wire, so they have same resistivity and same cross sectional area. So rho by A is common in both, so they cancel each other. So finally we get P by Q is equal to L1 by L2. And you also see, since this length is 100 centimeter, that is 1 meter, so certainly we can write L1 by L2 in terms of L1 only, means L1 and divided by 100 minus L1, because if this total length is 100 centimeter and this length is L1, so the remaining length has to be 100 minus L1. So we have done this. L1 by L2 is L1 by 100 minus L1. Now P is the known resistance. We select the resistance of our choice using a resistance box. In resistance box, what happens? We have certain resistances in series, and whichever plug we pull, that resistance come into play, and others remains dummy. So therefore the known resistance is selected from the resistance box. That value we can read directly on the resistance box. So P is now known to us. L1 we determine. How we determine? We find the state of null deflection in the galvanometer. For that length we find the length AAD, that is L1, for which we have no deflection in the galvanometer, that is the bridge is balanced. And once this is done, so we have now determined the L1, we have determined P, and nothing is unknown except Q. So we can find the unknown resistance of the of any unknown resistance, value of the unknown resistance Q, using this meter bridge. It is very helpful in finding the unknown resistance of any object, any resistance, etc. Here one thing you have to very much be particular about it. While doing experiment with a meter bridge, you need to essentially clean all the terminals where we have connected the wire, wherever you have a screw used to connect the wires. So you clean the terminal, the screw, the wire, etc., and then get them tightly fixed. If it is not done, your reading will not be there, because the proper flow of current is not happening. Another thing is the resistance of the resistance box should be selected such that the deflection, no deflection state is obtained in the center of the wire 1 meter long. That means it should be preferably, L1 should be preferably between 40 to 60. Value of L1 should be preferably between 40 centimeters to 60 centimeters, and for that situation our reading will be more accurate. That's all for today. Thank you and have a nice day.